What's going on, everyone? Welcome to the second episode of Proof of Code, my new YouTube series of videos about coding on the Cardano blockchain. Today I want to talk about the blockchain authentication mechanism that is a Catalyst winner proposal that for Fund 5 that I made early this year in April and eventually got funded in the last round of funding on Cardano. Before going forward, there are two messages that I want to give you. The first one is, if you like the content of this video, please like or thumbs up or subscribe to my channel. And please, if you're a technical person and you want to share the content I'm producing, share this video on the social media as well. The second thing is that this video will contain more conversational content as well as technical content. If any of those two is not your favorite, please don't quit the video, but just please use the time bar below and just go to the next section that could be of more interest to you. Without further ado, though, let's take a look at the proposal and what I've been working on so far. So here is the page of the proposal. The title is Blockchain Authentication Mechanism, and here there is a good description of what the project is. The core value of this thing is that in the close future when smart contracts will be released, Cardano is going to opening up to a new ecosystem of applications called dApps. Distributed or decentralized applications. In order to be decentralized from the ground up, they should have also the authentication layer made in a blockchain friendly way, and if possible decentralized as well. In the current IT industry, we've seen many authentication solutions that are very successful, but they all rely on a centralized distributed but centralized systems, like it could be Google or it could be that is using Auth.2 or your simple username and password that still they get persisted in an encrypted way on a centralized system. So if this system gets hacked, compromised, or it goes down or is unavailable, temporarily unavailable, you won't be able to log in on your dApps on the blockchain. This is of course fine, has been fine so far, but for the decentralized solution, we want something that is more native, more friendly, and this is the reason why we came up with this idea. The idea behind this is that you, as a user, as owner of a wallet of tokens on the blockchain, by the simple reason that you have a wallet, you can use your secret keys or protect secret keys of your wallet to authenticate yourself on the network. Of course, verification is different from identification. We're not talking about your name, last name, address, email, anything that is PII, personal identifiable information. We're talking about a digital identity, or simply a way to authenticate on the blockchain without saving this information in a centralized system. And the keys of your wallet, they are exactly this, like your way of being identified on the network. There are two types of authentication that can be done, and it really depends on who you are inside the system. On Cardano blockchain, because it's a proof of stake blockchain, there are really two entities. There are the SPOs and there are the delegators, with the delegators of course being in much larger number. Whenever you want to authenticate yourself on the blockchain, you can use your wallet to do so. Implementing this feature has been relatively simple, because the keys of the wallet, they follow a very well-known format, that is the IETF ED25519. That is simply an encryption, verifiable encryption mechanism. I will add more details to the official papers of this algorithm into the video description, and for handiness sake, they are also linked here in the repository of my project. In order to support the development of my project, I've created two different GitHub repositories that are available at Spindoing, that is an organization that I've created. And the first one is Blockchain Auth Mech Dev, And then that is basically the library that performs the authentication. And the second one is Speedwing Cardano Auth, that is basically an API or login server that is basically processing the login. Also, those two links will be provided into the description. As I was saying, there are two ways of authenticating. So if you are a delegator, you have your wallet keys, or if you are a stakeable operator, Andrew Westberg, Martin Lang, and Ola Allman, they have submitted a Cardano improvement proposal. So they proposed to use the VRF key of stakeable operator in order to verify a stakeable operator. Again, this is different from identify. This is just verify that a message, some information are signed by a stakeable operator. The proposal is absolutely exceptional. I am really happy with the work that is being done here. Kudos and hats off to both to all the three guys involved into this thing. And I've implemented both a login process with the signing keys of a wallet as well as the VRF keys of a stakeable. If you want to know, in a later section of this video, I'm going to show you the technical details about this and also a few lines of code. But for now, let's jump on an example. On the top, we're going to launch the API. This is going to take a couple of minutes. While in the bottom, we will be using the library just to send the message. Currently, I've implemented this in Java. Because it's the language that I'm most familiar with. Of course, once that I'm comfortable with the solution, I may try to ping other developers into the community and try to get this translated and migrated also to other languages, how it could be, for instance, TypeScript, Rust, Python, so on and so forth, so that we can have a rich set of clients that can communicate to the login server and have a very smooth experience on both back-end services as well and front-end services or website or dApps or whatever. So while the server is logging, the way this is going to work is basically the following. The client is going to attempt to access a resource that is protected, and the server is going to say unauthorized, this resource is protected. At that point, we're going to start the authentication process in which we ask the server for a message to be signed. Now, during the signature process, we also have to say whether we are a wallet owner, so a delegator, or if we are, or a simple ADA owner, that doesn't have to be necessarily a delegator, or if the client is a stakeable operator. We will sign the message and send it to the server along the public key, or also called the verification key. This is completely fine because it's exactly how the verification process happens in all the security context in the industry. At that point, if the server will verify that the message has been signed in a proper way and it matches the verification key, if that's the case, the user will be issued with a token called the JWT token, another technology that is widely adopted in the industry. And the client can use the JWT token as a way of authenticating against the server. It's like a secret key, but that identifies a client. Of course, the client does not have to share this secret because it's like sharing their own password. Once this is done, we will see how now the client using this JWT token set into the header like a bearer token, we will be able to eventually access the protected endpoint. So let's make an example. In the bottom, I'm going to try to access a protected endpoint. At this point, though this is a previous test that I was doing, we're going to remove the bearer token. We're just going to do a core-v. V stands for variables, so in this example, we're going to try to access a protected endpoint. Here, my service is now compiling and starting up. And in a couple of seconds, we should see the response down here that says 401 unauthorized. There we go. And this is because the endpoint is protected. So we can now start the challenge and we can ask the authentication challenge, and we can ask the server to give us an authorization message oops, I forgot the 0. We do need this because we need a random message issued by the server, otherwise we could be spoofing this information elsewhere. I will not go into too many details, but it's important that server and client agree on a random text, on a random message that needs to be encoded, it needs to be signed on the fly, so that client and server, they know they're actually talking to each other and no other messages have been spoofed elsewhere. So now this is the message that the server wants to be encoded. At this point, you can imagine that here we are only showing a proof of fully functional and working proof of concept, but if this was like a web page, this would happen, of course, all dynamically on a page and you wouldn't have to use client, etc. But in here, we are reproducing step by step what will be happening behind the scene. So here I have the Java library that implements the signature, and I'm going to be using it to sign the message. Here I put the message, I can actually put quotes, and then I'm going to be using the payment key file that is available. This is the normal file that can be that is used currently on the blockchain to talk to the blockchain. There we go. The library has now produced two outputs. The first one is the public key, that is the public key of the payment, and this is completely fine to share. And the second thing is the signed message. Now, for handiness, I've also pre-baked from the library the login message that needs to be produced in order to log in on the server. So I'm going to be showing you now what it contains. So the command is a curl, and basically it's a post. So we are talking to the server. We want to say that the content is a JSON. JSON is a textual representation of some data, and the content is the following. So message is exactly the same message as before. So this is the message that the server sent us, and we are now returning it and say, look, we are using this message. This is what you wanted me to sign. The second field is actually the signed message, and also this is fine to be shared. And this representation basically says, this is exactly what a wallet does when it signs a transaction. In this case, it's just assigning an arbitrary piece of text. And then last but not least, there is the public key. So the public key actually gets used to verify that a client really is what they claim to be. Last but not least, we also say what the signature type is. In this case, it's a payment because we're using payment keys. But in a minute, I'll show you how you can do the same with the VRF key, and you can authenticate against the server as if you were a stakeable operator. In this case, we are just signing up as a Cardano wallet owner. I repeat, it's also worth to say that the wallet can be empty, but regardless of that, we can still use the keys as a way of authenticating. We now have done the curl, and everything is gone fine. And because we are actually who we claimed we are, and the signature key is actually the correct one, the server is issued us with a bearer token, with the JWT token, that we can now use to authenticate against the protected resource. And I'm going to just paste the new token. Right, you can see that now something got printed also on the server side, and you can see that this is exactly the public key that was used earlier on. So we've been correctly identified by the server. They know that it's us, the 3749. Now, having the public key as the unique key to identify a user, it also enables us to potentially add additional information. So if, for instance, we are talking about a decentralized messaging system, I can add a nickname, I can add an email address, I can add whatever I want, but everything is going to get bind to the public key. And this public key, it's 100% sure, or 99.9999% sure that is always going to be my key. That are not going to be duplicated, as there are no duplicated wallets on the blockchain. And then the second thing here is that finally we tried to access the protected endpoint with the curl. We got a 200 OK, so the authentication passed. And the API is now returned. And the API is now returned a message to us. Hello wallet, because we are a wallet. The public key is yada yada yada. And the message is Cardano is the best blockchain. Don't you agree with that? So this is basically the proof of concept on and we can have like a number of protecting endpoint. We're going to be using exactly the same bearer token. As long as this bearer token is not going to be shared with anyone else, you're completely safe. This basically enables us to use to completely skip all the authentication mechanism like username, password, whatever. Whenever you get locked off by the platform, you just use your wallet, press a button, and the wallet will authenticate for you, because you are the, the unique and only one person owning that identity on the blockchain. And this is the first one. The second one is actually a second step that is extremely relevant with what I'm proposing now on Catalyst. That is Stakeboard. I guess that very soon I will publish a video just up here where you will find out what Stakeboard is. But Stakeboard basically is a secure, trusted platform to connect stake pool operators, delegators to stake pool operators. And you do know now that, for instance, one of the problems that we are seeing these days is that some pools, for instance, some stake pool operator, they own multiple pools, some of which they could be bogus. One example, I think, and I'm not sure about this, is for instance with Meld, where they have a number of pools, but I remember that at some stage there was like a Meld 4 or something that maybe wasn't really owned by Meld, but was someone trying to sneak in and create a stake pool and steal delegators' money. Of course, if there was a platform, a trusted platform where a stake pool operator could claim their own stake pools, and Meld was authenticated on the system, they can say 1 through 9 are all mine, but Meld 4 is not mine. I will not claim the stake pool, and immediately you will know in a verified, trusted way that Meld 4, and not on Twitter trying to dig through all the messages or Reddit or whatever, but you have one platform where everything is there and you can trust it, because we are providing stake pool operators and delegators a way of being verified, not identified, but verified. So of course, nothing against Meld, I'm just saying that there are people that are trying to steal other delegators' money in this way. Providing these tools to the community would be of fundamental importance. So let's do all over again. So the SIP 0022 is the pool verification. Andrew, Martin, and Ola, they've written all the code, all the steps in here. So I went through the code. Thank you to Andrew that has helped me, because there were a couple of things I couldn't make working. They are actually now working. And the content is all now down into the library, so you can actually use this without any problem. Let's do an example now. Instead of, we have to ask for a new message. So we get a new message. And this time around, whenever we are signing the message, we're going to be using a VRF SCI file. And in this case, I'm actually using the VRF signature file of my stake pool, Easy1, the Easy1 stake pool. And because I've minted at least one block, my VRF verification key has been stored on the actual blockchain. So this means that I've provided the API way of recognizing me. So if I do this, I'm going to be generating the usual stuff as before. The only difference is that now the signature type is VRF. Apologies. So if I copy and paste this, I will be able to log in, and I have my JWT token here. And if I'm gonna try to access the protected resource with the new token, there's actually something magic happening here. Hello, easy one. Because the verification key of the VRF key has been published on the blockchain, and because I'm authenticating with the VRF key, the server knows that this is a stake pool operator. And if I use the verification key and I go on the actual blockchain, I can retrieve all the information about this stake pool operator, because this stake pool operator is signed at least one block with the verification key. Of course, using metadata of the stake pool, I can derive what the ticker is. So now, assuming that the ticker is unique, you know that who it exactly is. But of course, we will be using, here is just an example, I'm using the ticker, but I should be really using the full stake pool identifier that is 2098, blah, 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 blah. But in this case, just as a simplicity, I use the ticker rather than the ID, so they could be like human readable. So this is the demonstration of how we can clearly identify stake pool operators and delegators or owners, other owners on the blockchain. And this is going to basically enable, again, Stakeboard to allow verified interaction on just one portal. No need to go on Twitter, no need to go on Reddit, no need to go emails, websites, whatever. You're going to have a verified, trusted platform where you can source all the information you want. And if stake pool operators, they want to add their personal website, they want to add their Twitter profile, they want to add their Reddit page, whatever, they can do that there, and you'll know who you're talking to. There are lots of scams on Twitter where they are creating copycat Twitter profile. And there are lots in our ecosystem, especially in Cardano, of successful influencers, YouTubers, Twitter accounts that have lots of copycat. And you think you're following the right person, but you're really reading tweets of someone else. And with this, I'm wrapping up for this video that has been already too long. I just want to say thank you very much. And please remember to like, thumbs up, subscribe, and share this video, and let me know what you think. Thanks and bye.